Hello everyone. A new concept, Cauchy sequence, is about to begin. Let's start with this concept. Consider a sequence x1 to be equal to 1, x2 equal to 1.4, x3 equal to 1.41, x4 is equal to 1.414, and so on. So I have took a sequence, the points x1, x2, x3, x4 to be like this. If I suppose my epsilon to be equal to 1 by 10, that means it is equal to 0.1. Then the mod of any two terms xn minus xm is strictly less than this epsilon for nm greater than equal to. What should I write? If I take my n to be equal to 1, this x1, and I take my xm to be equal to x2, then their difference cannot be strictly less than epsilon. That means their difference cannot be strictly less than 0.1. So if I guess my xn to be x2 or xm to be x3, then their difference, what is the difference of x3 and x2? 0.01. Now this difference is strictly less than this epsilon, 0.1. And if you take furthermore your xn to be x3 and xm to be x4, then also such difference is strictly less than 0.1. So xn minus xm mod strictly less than epsilon for nm greater than equal to, what should I write? For 2. If you take your n to be 2, m to be 2, that is x2 minus x2, then this is 0, which is also strictly less than 0.1. So you can take any nm but greater than equal to this 2. Right? Okay. Similarly, if epsilon is 1 by 100, which is equal to 0.01, then mod of xn minus xm strictly less than this epsilon for nm greater than equal to 3. Now this result is true if I take my nm to be greater than equal to 3. I should start from here. Similarly, for epsilon to be 1 by 1000, that is 0.001, then this mod is strictly less than epsilon for nm greater than equal to 4. So on we go like this. What is actually happening here? We are observing that for given epsilon positive, that is here if epsilon is 0.1, there exists a positive integer which depends upon the value of the epsilon, for which we get this mod to be strictly less than epsilon. Right? So each integer n depends upon the value of the epsilon and get I mod the difference of the terms of the sequence strictly less than this epsilon. Such a sequence is known as your Cauchy sequence. So we observe that for every given epsilon positive, there exists a positive integer n depending upon the value of epsilon such that mod of xn minus xm strictly less than epsilon for this nm greater than equal to n. So such a sequence is called Cauchy sequence, right? Now the definition for Cauchy sequence. A sequence Pn is said to be a Cauchy sequence in a metric space X if for given epsilon positive, there exists a positive integer n depending upon epsilon such that the distance between the terms of the sequence Pn, Pm strictly less than epsilon for this nm greater than equal to this positive integer n. That is, difference between any two terms of the sequence can be made as small as possible. Right? Alright. The other definition is for the diameter of E. Suppose E be a subset of metric space X, then a real number. This is the supremum of the dpq, that is distance between P and Q, where P and Q are the points of E. So the maximum distance, the supremum distance between the points of E is called the diameter of E. Right? There is a small concept. Suppose your En is equal to Pn, Pn plus 1, so on, which is equal to Pn where n is greater than equal to n, integer. What is E1 then? Put n equal to 1, you will get P1, P2, P3. What is E2? Put n equal to 2 over here and you will get P2, P3, P4. Then this E2 is a subset of E1, right? Because the points are starting from P2 and there is an extra point in E1, that is P1. So obviously this E2 is a subset of E1. So E1 is the bigger set, E2 is a subset of E1, and then E3 is again the subset of E2, and so on. And when this 1, 2, 3, if I apply this limit to be equal, this limit, this is nothing but your n, if I apply this limit n tending to infinity, what will happen to the diameter? Then this diameter will be equal to 0 because it goes like this. E4 is a subset of E3, so on, so on, so on. You get just just up to the point, the En, this number is increasing to infinity. You will get just a small, very, very, very small set. And then the distance between the points, the diameter En is tending to 0. Right? Now the remark. This is a very important remark. Let Pn be a sequence in a metric space X, and let En is equal to Pn, Pn plus 1, so on, which is equal to Pn where n is greater than equal to capital N. Then this Pn is a Cauchy sequence if and only if diameter En equal to 0. See, this capital N is your integer. The integer which depends upon the epsilon value, which depends upon the value of epsilon, and the small n are the subscripts of the sequences, the terms of the sequences. Small n is a subscript of the terms of the sequence, and capital N is a positive integer which depends upon the value of the epsilon, for which the distance between the terms of the sequence is strictly less than epsilon. Now what is given? We have given En, and we have to prove that this Pn is a Cauchy sequence if and only if diameter En is 0. So one way we have to prove that if Pn is a Cauchy sequence, then this diameter is 0. The other way, if the diameter is 0, then Pn is a Cauchy sequence. The two ways we have to prove. This remark you can take as your result, which can be used again and again in other theorems. So let's start with the proof. Suppose Pn is a Cauchy sequence. Let's start from here. Now writing the definition for the Cauchy sequence. Then, for given epsilon positive, there exists a positive integer n which depends upon the value of epsilon such that the distance between the terms of the sequence Pn is strictly less than epsilon for this nm greater than equal to this positive integer. Clear? Alright. Now see, this distance is strictly less than epsilon for all the terms of the sequence. You can take any two terms and your distance will be, the difference of the two terms will be strictly less than epsilon. So if this distance, any distance, is strictly less than epsilon, that means the supremum distance is also strictly less than epsilon. Because this thing is happening for any terms of the sequence. For all the terms of the sequence. That means some distance can be the supremum, right? And that supremum distance is also strictly less than epsilon because sequence is a Cauchy sequence. So the supremum distance where Pn and Pm belongs to capital En, it is given, right? This is less than epsilon because sequence is a Cauchy sequence. So all the distances, even the supremum distances, is also less than epsilon. And this supremum distance is nothing but the definition for the diameter of En. So can I write instead of this as diameter of En? Yes. This is nothing but the diameter of En, which is strictly less than epsilon. And epsilon was arbitrary. Epsilon was arbitrary. But you can take epsilon to be any small positive number nearer to 0. Therefore, if I take my limit n to infinity on this diameter En, then this thing will be equal to 0, right? Okay, now the other way, converse. What is given? Suppose the diameter of En is equal to 0 is given. Suppose, now we just have to reverse our steps back. This diameter En is 0. That means diameter of En means the supremum distance of the terms of the sequence is strictly less than epsilon. So then for every epsilon positive, we have, now we are mentioning the diameter of En. The definition, what is the definition for the diameter of En? I have just told you. Diameter of En, the definition is supremum of dpq where pq belongs to E. This is your diameter. So instead of diameter of En, can I write supremum of distance Pn, Pm such that Pn and Pm is belonging to this En. Now this distance, now the diameter is given to be equal to 0 for the limit n tending to infinity on En. So for any En, can I write this diameter strictly less than epsilon? Yes. If you take your n to be infinity for En, then this diameter will be approximately equal to 0. And this 0 is strictly less than this epsilon because epsilon itself is greater than 0, right? Epsilon itself is greater than 0. That means 0 is strictly less than this epsilon. And now for any En I take, E1, E2, E3, any En for En, the supremum distance is, can I write this distance is less than epsilon? Yes, all the distances are less than epsilon. Even the diameter is the supremum distance. The supremum distance of the points of En is also strictly less than epsilon. And which implies, now if the supremum distance, that is the maximum distance between the points, between the terms of the sequence is if less than epsilon, that means any distance is less than epsilon. If the supremum distance is less than epsilon, that means the other distances are also less than epsilon. For nm greater than equal to n. And this is nothing but the definition for the Cauchy sequence, right? So, but epsilon was arbitrary, which implies, therefore, Pn is a Cauchy sequence. This is nothing but the definition for the Cauchy sequence. So whenever this thing happens, we say that this Pn is a Cauchy sequence, right? Easy? Let's move further. There is one more theorem. If E bar is the closure of the set E in a metric space X, then diameter of E bar is equal to diameter of E. What is E bar? E bar is the closure of E. What is E bar actually equal to? The union of E and E dash, where E dash is the set of derived set. Derived set means set of limit points of E. Which is known as the derived set. So this E bar is equal to union of E and E dash, right? Obviously, this E is a subset of E bar. Can I say this from here? Yes. Let's start with the proof now. Now, what is given? E is the closure of the set E. We have to prove diameter of E bar is equal to diameter of E. Now, since E bar is equal to E union E dash, that means E is the subset of E bar. Therefore, if E is a subset of E bar, that means diameter of E is less than equal to diameter of E bar. Clear? Right. Which implies diameter of E bar, take this to the other side, diameter of E is greater than equal to 0. Clear? Take this to be as 1. Alright. Now let's have epsilon positive. Let's define. Let epsilon be taken to be a positive real number. This be given. And let's take 2 points P and Q from this E bar. Right? Now whenever this PQ belongs to E bar, what does this mean? Either PQ belongs to E or PQ does not belongs to E. Because E is contained in E bar. Suppose this is your E bar and E is the subset of E bar. Now if you take any 2 points from E bar, suppose I take P and Q, then this PQ either belongs to E or does not belongs to E. Because the points of E are also the points of E bar. Right? So this PQ can be contained in E or cannot be contained in E. If this PQ belongs to E, then we can say the distance of the points of E with E bar, we can manage their distance to be less than any epsilon, right? But if PQ does not belongs to E, see, again I will explain. This is your E bar and this is your E. Suppose these 2 points belongs to E. So I can manage the distance of 1 point with the distance of 1 point with the point of E bar. I can manage this distance to be strictly less than epsilon or epsilon by 2 or so on. I can manage that distance. Suppose if PQ does not belongs to E, then what are PQ then? then PQ are the limit points of E, right? Because E bar is nothing but the E union E bar. Either points belongs to E, and if point does not belong to E, then that point belongs to E dash, the set of limit points. Then if PQ does not belongs to E, then these PQ are the limit points of E. And if PQ are the limit points of E, that means neighborhood of P. There exists a neighborhood of P, and you can take their radius to be epsilon by 2 or epsilon, such that its difference, the distance between or the difference of the point P with the point with E or E bar is less than epsilon by 2. You can manage that distance. Alright. So, in both the cases, we can manage our distance of the points of E with the points of E bar to be less than epsilon by 2. We can manage that distance. We can take that distance. Now let PQ belongs to E bar. Then there exist the points P dash and Q dash which belongs to E such that distance with P and P dash is less than epsilon by 2 and distance of Q and Q dash is less than epsilon by 2. See, if what are PQ? PQ are the points of E bar and P dash Q dash are the points of E. Distance of the point, one point from E bar and one point from E, that is distance between these 2 points. I can take that distance to be less than epsilon by 2. Yes, because if P dash belongs to E, I can manage this distance because P dash is present in E, and if P is also present in E, then this distance can also be taken as epsilon by 2. Whether P present in E or if it is not present in E, my distance can always be strictly less than epsilon by 2, because if P does not belong to E, that means this P is a limit point of E. And with the definition of the limit point of E, its neighborhood contains a point of E other than this point. You know, if P is a limit point of E, then neighborhood of P, there exists neighborhood of P such that which contains a point of E other than this P, right? And also this E is contained in E bar. That means the distance between the points of E bar and E can also be less than equal to less than epsilon by 2, right? We can take in both the cases their distances to be less than epsilon by 2 or any epsilon. We can manage both the cases. We can manage the distance for both the cases to be less than epsilon by 2, right? Don't confuse with that. All the points which are belonging to E or which does not belongs to E are the points actually belonging to E bar, right? So in E bar, you can take the distance of any 2 points to be less than epsilon by 2 or less than epsilon or less than epsilon by 3. You can take any epsilon because epsilon is arbitrary and it is a positive number, real number, right? I suppose this is clear to you. So just we have to take the 2 points from E bar and 2 points from E and getting their distances to be like this. Now taking the distance of the points E bar. What this distance? This distance can be written as strictly less than, this distance is less than equal to d of P dash plus d of P dash Q dash plus d of q dash q, right? Now this d of pp dash is strictly less than epsilon by 2 plus d of p dash q dash, and this distance is also less than epsilon by 2. So what is this distance? P dash and q dash are the points of E, and this distance will be less than equal to the diameter of E. Because what is the diameter of E? Diameter of E is the maximum distance. So this distance is less than equal to the maximum distance in E. So can I write for this to be less than equal to diameter of E? Diameter of E plus this sum is epsilon, which implies distance of PQ is less than epsilon plus diameter of E. Here we should write as P dash and Q dash belongs to E. That is why I mentioned the diameter of E to this distance. Now this is less than epsilon plus diameter of E. For all, this PQ are belonging to E bar, right? So taking the supremum now, taking the supremum on for all PQ belonging to E bar, we get diameter. Now taking the supremum on this distance means diameter of E bar less than epsilon plus diameter of E, which implies diameter of E bar minus diameter of E is strictly less than epsilon. Take this equation to be as 2. Now from 1 and 2, what is our first equation? This diameter difference is greater than or equal to 0, and the second one, this is less than epsilon. That means 0 less than or equal to diameter of E bar minus diameter of E, which is less than epsilon, which implies mod of diameter E bar minus diameter E is equal to 0, which further implies this difference diameter E bar minus diameter. If mod is 0, that means inside what is there is equal to 0. Furthermore, finally we got our result, that is diameter of E bar is equal to diameter of E. Hence the result. So next time we will do some more theorems. So just revise this concept again for the next video. Thank you for watching this video. Have a nice and good day. Goodbye.